This video is an introduction to conditional statements. At the end of the video, we'll also cover the converse, the inverse, and the contrapositive. The conditional statement is a logical statement that has two parts, and the hypothesis is the part that comes with the if, and the conclusion is the then. So a conditional is saying if the hypothesis comes true, then the conclusion will naturally follow. Here's an example. If it is Friday, then the cafeteria will serves gyoza. So if this hypothesis comes true, if you wake up in the morning and you say, oh yes, it is Friday, then the conclusion will happen. The cafeteria serves gyoza. I'd like to point out, though, that not all conditionals are true. Some of them you'll classify as false. So let's see if you can write this as a conditional. Vertical angles have the same measure. So why don't you hit pause right now? Write down what you think this could be in if-then form, and then come back and check. Let's see if we wrote the same thing. Vertical angles have the same measure. So if two angles are vertical, I'm testing the first part of the statement to see if you're a member of this group. Are you a vertical angle? If you are a member of a vertical angle, then the conclusion would follow. You would have the same measure. If two angles are vertical, they have the same measure. Let's try another one. Volleyball players travel to Yokota tonight. Again, why don't you hit pause? Okay, you're back. Let's see if we wrote the same thing. If you are a volleyball player, then you travel to Yokota tonight. So we're checking to see if you're a member of this first group, volleyball players. And if you are, if you fulfilled the hypothesis, then the conclusion is that you'll travel to Yokota tonight. You have to be very careful with the English language that you're communicating what you want to communicate. If your hypothesis is testing something different, then your conclusion will be different as well, and what you're communicating might not be what you want to communicate. Now, counterexamples are examples where you show that the statement is not always true. Not all conditionals are true. In order to prove a conditional false, you have to have the hypothesis that works, but the conclusion that doesn't. So if you are a volleyball coach, then you are female. Let's underline the hypothesis. You are a volleyball coach. Notice I'm not underlining the word if. You are female is the conclusion. So in order to show that you have a counterexample, you want the hypothesis to be true, but the conclusion to be false. So can you think of a volleyball coach that's not female? And if you're thinking about volleyball at ASAJ, your counterexample could be Mr. McCall. He is a volleyball coach. He's not female. How about this one? If x squared equals 16, then x equals 4. So you're going to try to come up with an x where this part is true, the hypothesis is true, but the conclusion is false. Can you think of anything that we could use for a counterexample? Hopefully you said -4, because if you put -4 in the hypothesis, x squared would be 16, but x is not equal to 4. There's other kinds of parts of conditionals as well, or other ways of representing a conditional. If you start with a conditional, if an angle measures 90 degrees, then it is a right angle. So the red part is the hypothesis, and the green part is the conclusion. If you reverse those two and put the conclusion first and the hypothesis second, but leave the if and the then, it's called the converse. Notice we've had to play with the English language a little bit, though. Here you see an angle, but down here you see the word it. And it's okay if you need to change your pronoun. Keep in mind what your English teacher has taught you about sentence structure. So if you reverse the hypothesis and the conclusion, it's called the converse. Let's keep going with that same conditional. If you don't reverse them, but you negate it, so if an angle doesn't measure 90 degrees, then it's not a right angle. That's called the inverse. I didn't switch the hypothesis and the conclusion, I just negated them. And if you switch them and negate it, you would end up with, if an angle is not a right angle, then it does not measure 90 degrees, and that's called the contrapositive. It's the inverse of the converse. So let's summarize this a little bit because those conditionals were kind of wordy. If your conditional is if X, then Y, your converse would be if Y, then X. Your inverse would be if not X, then not Y. And your contrapositive would be if not Y, then not X. And the question is which two are equivalent, and it means logically equivalent, and it's the first one and the last one. If the conditional is true, the contrapositive is true. If the conditional is false, the contrapositive is false.